So the first 10-minute math part 1 is, which is not a factor pair for 18? A, B, C, or D? And before we go and kind of discuss which one is not, I want to talk about, and we've gone over this a lot, so I'm hoping somebody can tell me, what are factors? Somebody besides CJ, what are factors? Anybody? Somebody? Michael, thank you, sir. What are factors?
Something we can use an equation that equals that number. So
you're on the right track, right? I think when you say equation that equals that number, what kind of equation? Like, what kind of operation are we doing? Addition, subtraction, multiplication?
Multiplication.
Multiplication. And they're the two numbers that we do what with? You're on the right track. Can somebody help Michael out? So he knows that they're two of the numbers in multiplication equation. What do we do with those two numbers? Jay, you had your hand up earlier. What are factors?
Factors are two numbers in a multiplication problem that gets an answer.
And what do we call the answer of a multiplication problem? Anybody know that one? CJ, you can share that one. What do you call the answer in a multiplication product? Oh, product, right? So CJ's got a little visual on his whiteboard. Factors are the two numbers we multiply together to find a product, right? And the product is the answer to a multiplication equation. So what we're saying here is which one, I'm going to give you a minute to think about it. What factor pair is not a factor pair for 18? Meaning, which one of those do we multiply together that will not give us 18? So 1 times 18, 4 times 7, 3 times 6, or 2 times 9?
No.
Which ones do not equal 18? All right, I'm going to give you 30 seconds to think about it, and then we're going to share our responses. All right, which one of those factor pairs do we think does not equal 18? Ania, which one do you think?
Letter C.
C, so we think 3 times 6 does not equal 18. Give me a thumbs up if you agree with Ania. Give me a thumbs to the side if you think it might be something else. So we have some people who disagree. We're going to let them state their case, okay? Cynthia, you had your hand up. Which one do you think it is?
B.
B. So Cynthia says B, 4 and 7. Why, Cynthia, why do you say B, 4 and 7?
Because 4 times 7 equals 28.
So Cynthia says 4 times 7 equals 28. So let's check these two, and we'll see. We're going to make an array to check 3 times 6, and we're going to see if that equals 18, okay? So let's go 1, 2, 3, 4, 5, 6. There's 1 times 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 6 plus 6 plus 6. What does 6 plus 6 plus 6 equal, or 3 times 6? Jay?
18.
18. So we have 3 times 6 equals 18. So do we want to change our answer maybe a little bit, Ania? Do we want to agree with Cynthia? Yeah. B would be right, because 4 times 7 equals 28. So that would be the one that does not go. We know 1 times 18 does for sure. 2 times 9, if you double 9 or do 9 plus 9, you also get 18. All right? So that would be correct, 4 and 7. Let's move on to quick images. So you need your whiteboard for this one. Since we did that part 1, we're only going to do one of these today. So here in just a second, I'm going to show you an image for 30 seconds. No, 3 seconds. Then you're going to have 30 seconds to draw it or try to remember it and draw it. And then we'll come back and look at it, one more time, finish our drawing, and then write an equation to go with it. So on your marks, here starts your 3 seconds. 1, 2, 3, here it is. Wait, I got people looking the other way, so I'm going to give them a second. All right, 1, 2, 3, here it is. And I'm covering it up. So I will give you 30 seconds to work on trying to draw that, and then I will show it to you again for 3 more seconds. I have a friend who probably needs to put a plastic down and be a little bit more focused right now. All right, 10 more seconds. I'm going to show you it again. All right, here it is again. Ready? 1, 2, 3. You get 3 seconds. I'm going to cover it up again, and you have 30 seconds, or I'll give you a minute to draw it, and then write in a multiplication equation that you think goes with that picture. All right, you have 1 minute. I'm noticing Alex J working hard on this. Thank you, and Cynthia and Michael. I can see Corbin and CJ, and Denise and Alejandro are all working. Thank you. Looks like Dunya and Kayla are also working hard. Thank you, guys. All righty, I'm going to uncover it. And is there somebody who would like to share the equation they wrote to go with this image? Somebody I've not heard from yet. Michael, I appreciate you raising your hand, but I've heard from you a lot today. Same with you, Jay. Corbin, why don't you go ahead? What is a multiplication equation you wrote to go with that image? You're muted, bud.
Nine times 7 equals 53.
63. Where did you see 9? How did you get 9 times 7?
Oh, wait, no.
All right, I'll let you think about that for a minute now that you can see it. Somebody else want to share an equation that they wrote down that goes with it? Clay, what did you write?
3
Okay.
times.
Hang on. Can you start over again? Somebody was loud on there.
3 times 16.
All right. How did you get 3 times 16? Talk us through that.
Well, because I counted and knew 4 plus 4 equals 8. And I think 8 plus 8 equals 16.
So right? Did you look at it like this? Like you have 4, 8, 12, 16 in that group right there?
Yes.
And then another group of 16. Okay. And then another group of 16. So really what you did was you looked at groups of 4 kind of like this, but then you added those all together, right? To get 3 groups of 16. Okay. So let's do that. We'll start with, since it's 16 is not a fact we know, we can do 16 plus 16. 6 plus 6, we get 12. 1 is 32. And then we do one more, 32 plus 16. 2 plus 6 is 8. 3 plus 1 is 4. And we get 48. So there was Clay's answer. Did anybody else see it a different way? Did anybody else get one that was different besides 3 times 6 equals 48?
Can I go?
Go quickly, please. We'll do one more. Ania, what did you get? How did you do it?
I got 12 times 4.
So 12 times 4 equals 48. And then did you look at it? Where did you saw 12 groups of 4 like this? Is that how you looked at it?
Mm-hmm.
Like 1 group, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 12 groups of 4 got the same answer, right? Just how we can kind of see those are grouped differently. Did anybody see groups of 6 in there? Just curious. Or groups of 8? Jay, so you saw groups of 6. So if you saw groups of 6, Jay, did you look at it like this, like a regular array, kind of like you had a group of 6 right there, and you had 8 groups of 6? That also would equal 48, right? So is the number 48, this is a risky question I'm about, prime or composite? And how do you know? Is the number 48 prime or composite, and how do you know? Michael.
It's composite because 48 is an even number.
Okay, so we know it's composite because 48 is an even number. So yes, that's one way to know. Also, how many factor pairs do we have sitting down here that we just talked about? Look at all these. We have 3 factor pairs right here, right? So all of those numbers right there are factors of 48, meaning we could use them to multiply to find 48. So awesome work. It's a composite number. Moving forward, we are going to look at some of those multiplicative comparison problems, right? Again today. And what we mean with multiplicative, why does it keep doing this to me today? What we mean when we talk about multiplicative comparisons, sizes, or objects, and we're using multiplication. We've talked sizes or objects, and we're using multiplication. We've looked at these last week. We're going to look at them more in some detail again this week. So we're going to first take a minute and just review one of those problems and how they work. So is there anybody who would volunteer, please, to read this first problem for us today? I'm going to share my screen. I don't know what happened. It went away. There we go. CJ, can you read the problem for us?
Miles works very hard at his job, and so does Clay. Miles works 7 hours in a week. Clay works 5 times as much as Miles. How many hours does Clay work in a week?
Dang, Clay, you work a lot. All right, does anybody have one thing in here that we could underline or circle that is important to the problem that we need to know to help us solve the problem? What's one piece of information in there? Alex J, give me one thing that's important in that problem.
One thing that is important is how many hours does Clay work?
All right, so it's asking us the question, right? So our question we're trying to answer is how many hours does Clay work in a week? So there's one thing. That's the question we have to answer. Denise, what's something else that's important in that problem?
The hours.
Yeah, specifically which ones?
The 7 hours and
So stop. Who works 7 hours? Miles or Clay?
Miles.
Yeah. So Miles works 7 hours. All right. And then there's one other thing we have to pay a lot of attention to. And what is it, Henry? What's the other thing in there that we need to pay attention to?
5 times.
Yeah. Clay works 5 times as much as Miles. All right. So we know Miles, if we put tally marks, works for how many hours? Anybody can unmute. How many hours does Miles work?
7 hours.
7 hours. 1, 2, 3, 4, 5, 6, 7. So there's miles right there, 7 hours. If we're looking at clay, what do we need to do to find out how many hours clay works? Raise your hand if you can tell me. What do we need to do to find out how many hours clay works? Clay, what do we need to do?
We need to, since there's 7 right there, Miles says 7, and it says Clay works 5 times as much as Miles. We just double that by 5.
So we don't double it, because if we double it, here's what doubling means. So that means we would go 1, 2, 3, 4, 5, 6, 7. There's 1 time. 1, 2, 3, 4, 5, 6, 7. That would be doubling. So are we doubling it? What do you mean double it by 5? I guess let's clarify your thinking. What do you mean by that?
I mean by add 5 more.
So we need to do it. Are we adding 5 more hours, or are we adding 5 more groups of 7? That's a tricky question. Somebody help Clay out, clarify this a little bit, what we're supposed to be doing here. DJ.
Groups of 7.
So we need 5 groups of 7, right? Because it says Miles does 7 hours. Clay works 5 times as much. So we're going to say 1, there's 1 time as many, 2, and then do 1, 2, 3, 4, 5, 6, 7, 3, 1, 2, 3, 4, 5, 6, 7, 4, and then 1, 2, 3, 4, 5, 6, 7. So now we have 5 times as many, right? If it said Clay works 5 more hours than Miles, then we would do 7 plus 5, but it doesn't. It says 5 times as many. So now what is an equation that we could use to represent the answer to our problem? Let's see. Somebody I've not heard from. Cynthia. I think we have heard from you, but that's okay. Cynthia, what would be our multiplication equation for this problem?
5 times 7.
5 groups times 7 in each group equals what? Anybody know 7 times 5? That's a math fact we should be working on knowing. Corbin, what's 7 times 5?
35.
35 what?
Hours.
Hours. Thank you, sir. All right, we're going to look at one more that's a little bit tricky. All right. Let's see. Alex J., can you read this one for us, please?
Andrew picked 7 yellow roses and 28 red roses. How many times as many roses did Andrew pick than yellow roses?
All right, so this one's a little tricky the way it's worded, so we're going to really take a minute to talk about it. Mary Lay, what is one important part of this problem that we could underline or circle that's important? Just one part.
The numbers.
Yep, 7 yellow roses. Thank you. What is something else that's important that we could circle in this problem? Eric.
What?
What's something else in this problem that's important that we could circle that we know to highlight that we understand it? We know there are 7 yellow roses. What about the 28 red roses? Is that important?
Yeah, I think.
Okay. So we're going to put a circle. We're going to circle that part. 28 red roses. And then what is this question asking us, Ania?
It's asking us, it says, how many times as many red roses did Andrew pick than yellow roses?
Yep. It's asking us how many times as many red roses. So on this one, this is where we're going to have to draw a picture. I'm going to move my little dot down so I can see a little better. All right, so I'm going to.
Mr. Hoffman, also, besides drawing the picture, could we also make that grid that you use sometimes
Oh, the
to
table.
maybe the table to visualize it?
Yep. So on this one, if I make my table, actually, I'm going to make it up here on the white part. We know that my, let's see, number of groups. We have the objects per group, OPG, and then we have the total. So this is what's kind of tricky about this one. This is a little bit different than anything we've ever seen before. All right. We know we're comparing the 28 to the 7. So really there's 35 roses, but it's not asking us to split up the 35 roses, right? So this is what's tricky. We don't know how many groups we have. We don't know how many objects are in a group because it's asking us to do that work on our own, right? So we're going to try to fill this table out at the end after we kind of make a representation to help us understand a little bit. All right, so if I have the yellow roses and I made just one group, I'm going to put these little yellow things. There's 1, 2, 3, 4, 5, 6, and 7. So there are my 7. There's my yellow roses, right? And then I'm going to do pink because it still shows up a little bit better. But we're going to do these at the bottom. Is there a number we can multiply to get 28? Can we multiply 7 times something to get 28? Do we know that math fact? Let's just see if we can put the red roses in groups of 7. All right. So 1, 2, 3, 4, 5, 6, 7. How many red roses do I have altogether? Can somebody remind me? How many red roses are there altogether? You can just unmute and tell me.
28.
28. So I'm going to make these. So I'm 7, now 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25,
Wait, it doesn't let us open the form?
27, and 28. So look, I have groups of
Okay,
7.
how about documentation?
How many? Hang on.
Maybe the form browser just
Somebody who's unmuted. I need you to mute. I think Jay.
I'm trying to figure out who that is. Oh, there we go.
It might have been Jay. Thank you. Okay. So in this problem, how many roses are in each of my groups, everybody? And in both yellow or orange, how many roses are in each group? How many are inside the circles? Jay's holding up on his finger, right? There's 7. So my objects per group is 7 in this problem. Now here's what's tricky. We're comparing 28 to one group. So we actually are using 28 as our total. And if we have 7 per group and we're trying to figure out the number of groups, that's like saying blank times 7 equals 28. What would be another way of saying that? What would be another way of saying blank times 7 equals 28? It's a little tricky. Anybody know? Ania, what's another way we could write an equation instead of blank times 7?
28. 1 divide.
Say it, your comment. You're right. 28 divided by 7, right? So then we look at our bottom drawing. How many groups of 7 did we have for 28 roses? Cynthia?
4.
4, right? 4. So this is where, which one of those is our answers? How many times as many roses we had? 4. So we're going to say 4 times as many red roses. I don't think you guys have any that are that tricky today, but you will see some like that every once in a while, so it's important we take a look. It's not always simply just multiplying like the first one was. Sometimes you're going to get those tricky ones that kind of throw in division. All right, your job today is you are going to go out and you're going to create a model or a picture and solve 3 comparison problems. Notice my funny little meme that I thought was hilarious to the side. It's the little guys deciding which button to press. It says show all work and get full credit, or save time, and who are turning their work in without showing work or out explaining answers, and they're missing points assignments. They're getting the right answers, but they're missing points for not doing that second piece of work, okay? So make sure you're showing your work and showing us how you got that answer, okay? I'm going to pull up the assignment just so you guys can see what it looks like. It is on Wednesday, and it says math, and it's comparison problem review. There are 3 problems, all right? And it says, solve the comparison problems below, then in written words, explain the steps you follow to solve each problem. Below the problems, there's
Mr. Hoffman, do you
We
want us
can't
to
see
see the
it.
screen? We still see your flip chart.
Why does it keep doing this to me?
Are you, that happened to me also. I had to re-record my vocabulary.
Let's try to, hang on a second. Stop sharing. Let's try to share it again.
Maybe were you sharing it only that screen instead of sharing your desktop?
No, I pick desktop every time because I always go back and forth. Is it working now though? Can you see it now?
Yes.
Okay, cool. So on this one, it says there are problems below. There's a sample problem if you get stuck. So you can see in the bottom, it says the book that Cynthia's reading is 7 times as long as the book Angel's reading. Angel's book is 8 pages. How long is Cynthia's book? So I said I use an array model, and there's an example of an array that you could use to help solve the problem. Then here, look at this explanation. I knew that Angel's book had 8 pages. So in his array, I drew only 1 column of 8 because those are his 8 pages. Cynthia's book was 7 times longer. So I drew that what Angel had 7 times. This made the array for Cynthia 7 columns of 8. Then I counted all the dots I drew for Cynthia, and I got 56. Cynthia's book is 56 pages long. So you need to draw a model and explain how you got your problem to get full points, how you got your answer to get full points. There's only 3 of these, so you guys have, and we're actually done a little bit earlier than normal today, so you guys should have plenty of time to get that done, all right? I had 21 people on reading today, and I have 15 assignments submitted. So when you get done with math, if you've not done it yet, you need to go back and submit reading, all right? Every single person needs to get on office hours today and check in with me. Every single person. I get half the time, I only have half of you guys. Please get on and at least check. If you're done with everything, I just tell you, see you later. If you're not, we're helping people get, I will give Derek a bunch of credit. Derek gets on every day. He asks what he needs to do. And last week he went back and he got the stuff done and he had every single assignment done, right? So props to Derek for doing that. We're here to help you guys during those hours. So please get on and double check with us. All right. I'm going to stop sharing my screen and I'm going to stop recording.